Question 5. The force F newtons exerted by a magnet on a metal object is inversely proportional to the square of the distance d centimeters. When d equals 2 centimeters, F equals 50 newtons. Express F in terms of d. Let's not get ourselves sort of, too worried about it to begin with. Let's just have a look where I'm going to start. F newtons is inversely proportional to the square of the distance d. So F, we know that for inversely proportional, it's k over the thing which it's inversely proportional to, which is the square of the distance d. So d squared. I've set it up. Now I just need to substitute in the values that I know to work out what k is. So I do have a pair of values here. F is 50 and d is 2. So 50 equals k over 2 squared. Okay. So 50 equals k over 4, because 2 squared is 4. So if I times both sides by 4, I have 200 equals k. That's not finished. I've not finished my work here. I need to now rewrite this out, but I now know k. So F equals 200 over d squared. And that's it. 200 over d squared. So I find k and then I resubstitute it in. Okay, part B. Find the force when the distance between the magnet and the metal object is 10 centimeters. So the distance is 10 centimeters. So I'm going to rewrite the whole thing that I've got. I know what k is now, which is 200. I'm going to put it over 10 squared because I've just been given what the distance is, and the distance squared. So I'm going to rewrite that out as F equals 200 over 100 because 10 squared is 100. And now I can work out what F is, isn't it? Can't I? F equals 200 over 100, which 200 divided by 100 is just 2. If you want to cancel zeros, you can, because it's the same as 2 over 1, which is just 2. 2 newtons. Okay. Part C. Find the distance between the magnet and the metal object when the force is 8 newtons. So now I've been given the force of 8, so I'm just substituting into my formula now, and my formula is this. But I'm being given my 8 part, so 8 equals 200 over d squared. And I need to rearrange this so I have d to make d the subject. So if I times both sides by d squared, then I get 8d squared equals 200. And then if I divide both sides by 8, I get d squared, so divide by 8, divide by 8, I get d squared equals 200 over 8. Now 200 divided by 8, well 200 divided by let's say 4 would be 50, so 200 divided by 8 is 25, so d squared equals 25. If d squared equals 25, I'm now going to take the square root, so d would be equal to 5. It's also minus 5, but you couldn't have a distance minus 5, so I can exclude that. That's not, in the real world, in this situation, it would be a positive value. So my distance is 5 centimeters. So my last question asks me to explain what happens to F when d is halved. Well, this is half the distance of this one, okay, and the force went up from 2 to 8. So the force was multiplied by 4 when the distance was halved. And what has actually happened, and I don't know if they require it for this, is that the force has actually been multiplied by 2 squared, because it's inversely proportional to the square of the distance. So I can also say force was multiplied by the square, by 2 squared, which we've kind of already said there with 4. If they would word it slightly differently if they want you to really explain that in more detail. So that's question 5.